For decades, we thought we understood the farthest rock in our solar system, but almost everything about Pluto's history, from the moment we discovered it to the day we publicly humiliated it, was driven by monumental scientific errors. In August 2006, astronomers gathered at the International Astronomical Union in Paris and voted to officially strip Pluto of its planet title. The IAU decided that a true planet must meet 3 strict conditions. It has to orbit the sun, it has to be massive enough to pull itself into a sphere, and it must clear its orbital neighborhood. Because Pluto only holds 0.2% of the mass of Earth, it simply doesn't have the gravity to push out the icy space debris crowding its path. It was instantly downgraded to a dwarf planet. But looking back at the math that found Pluto in the first place, its demotion makes perfect sense. Early 20th century astronomers noticed that Uranus was wobbling off its expected path. Based on the laws of physics, they assumed a massive, unseen world, which they called Planet X, was gravitationally dragging Uranus out of its orbit. An American astronomer named Percival Lowell became obsessed with finding this heavy ghost planet. He even built a dedicated facility in Arizona, pouring his own resources into scanning the night sky for this gravitational giant. He didn't live to see it, but in 1930, a 23-year-old researcher named Clyde Tombaugh spotted a tiny dot moving across the starfield. Astronomers assumed Planet X was finally real. That theory held up until 1989, when the Voyager 2 probe flew past Neptune and sent back new measurements that rewrote the textbooks. This animated equation shows exactly what went wrong. The original calculations for Neptune's mass were too high. By dropping the mass by just 0.5% to match the new Voyager data, the mysterious gravitational wobble in Uranus's orbit vanished entirely.
There was no massive gravitational giant out there. Astronomers spent decades searching for a phantom planet and accidentally stumbled onto a tiny, freezing ice ball in the dark. To see what that rock actually looked like, NASA launched the piano-sized New Horizons probe. It spent 9 grueling years crossing 3 billion miles before finally arriving at Pluto in 2015. It beamed back images of a massive, perfectly formed heart-shaped plateau, now called Sputnik Planitia. But looking closely at this heart, the nitrogen ice surface is completely free of impact craters. Instead, it is covered in strange geometric polygons and small pits that look exactly like crab holes on a beach. This cross-section shows the bizarre geological mechanism carving those shapes. Because the environment is extremely cold, solid nitrogen ice vaporizes straight into a gas, skipping the liquid phase entirely, a process called sublimation. Deep underground, the planet's internal heat melts the nitrogen. It rises to the surface, freezes, and sublimates again. This churning convection loop smooths over any fresh craters. High above the ice, ultraviolet sunlight reacts with methane in the thin atmosphere to create tholins. These are toxic, reddish-orange organic compounds that fall back down like snow, staining the surface of Pluto and its moon Charon. Pluto functions as a highly active chemical engine, governed by physical rules that have no parallel on Earth. That activity extends to literal cryovolcanoes on the surface. Instead of spewing molten rock, they erupt a freezing slush of water, methane, and ammonia. Looking at this 3D model, you can see how this internal activity explains a massive gravitational anomaly. Researcher Francis Nimmo found that over millions of years, as nitrogen ice filled the giant impact crater of the Hart Plateau, it became incredibly heavy. That localized mass physically forced the entire planetary axis to tilt sideways. But nitrogen ice isn't heavy enough alone. The math balances only if you peel back the crust, revealing a massive hidden liquid ocean underneath. That mathematical error from 1930 led us to an active world that maintains a massive liquid ocean beneath its frozen crust. After analyzing Pluto, New Horizons didn't stop. It pushed millions of miles further into the dark outer edges of the solar system, entering the Kuiper Belt. Out there, the probe spotted Arrokoth, a strange snowman-shaped object floating quietly in the void. Its smooth reddish structure is crucial because it shows zero signs of a violent impact. It proves that the two halves gently fused together over eons. Because things move so slowly and remain undisturbed at this distance, objects like Aerokoth act as pristine time capsules. They preserve the exact conditions of how our solar system formed 4.5 billion years ago. Reclassifying Pluto redefined it as the primary gateway to the Kuiper Belt, a vast, ancient junkyard that holds the blueprint of our solar system. We went from chasing a phantom planet with bad math to finding a blurry dot in 1930, to witnessing a hyper-detailed world in 2015. Pluto boasts a beating nitrogen heart, towering ice volcanoes, and a hidden underground ocean. Science advances by correcting its own errors. In the cosmos, a world's importance isn't defined by its size or a title, but by the complex geological activity occurring miles below its crust. Subscribe for more deep space deep dives.